All right, again, keeping up with notes. This should be notes number 3. And most of that's kind of there for me just to make sure I'm keeping everything straight as we're going through this stuff. Okay, so we've got some different things here. Now, we got point slope formula as we're going through some stuff on this one. If you do or don't remember point slope formula from way back when, this is the one that's kind of the longer of the two, but it's y minus y1 equals m times x minus x1. Okay, and anytime we're working through slope, anytime we're doing anything with equations, if you ever get stuck, this is kind of where you want to go. So that's the only thing I always tell people. Hey, if you get stuck, this is where you want to start here. Because you can always take this equation and rewrite it and do, any one of a number of things that you can do. Sometimes there's some that you need that you can only work with, but this is one. If you start here, you can go anywhere and do anything you want to do. So just kind of keep that one in the back of your head there. If you ever get stuck on some of this stuff, that's what we're looking at. Okay, so with this one, as we're going through these, this is your first point here. So this would be x1 and y1. They told us that this m is -4. So we got that one. So that's the numbers we're going to plug in. Okay, so for this equation back up here, we're going to do y minus, in that case y1 is 7. And then equals your m value here, which is -4, times x minus x1 is -1. Okay. And anytime you plug in negative numbers, sometimes positive numbers will do it too, but anytime you plug in negative numbers, always put those numbers in parentheses because that will kind of help you see that for this part of it, we've got this minus negative that's here, that you've got to take that minus negative and change it and make it a positive number. Okay, and then if they ask you just to leave it in point slope formula, that's all you got to do. So basically, you're just plugging in the numbers, and if you've got some minus negatives, then you want to clean those up just a little bit. Okay, second one, pretty much the same thing. That again, you've got your numbers here, so that's your x1 and your y1. And again, we're just going to plug that back in up here. So it's y minus. Now in that case, y1 is negative. So when you plug it in, it's the -5 there. Equals m in this case is 2/3 times x minus x1, which is -6. Okay, so same thing on this one. You just need to clean up the two minus negatives. So make that y plus 5 equals 2/3 times x plus 6. Okay, now and sometimes they'll let you leave the answers like that for everything that you're doing as we're going through all the parts on this one. Sometimes they're going to ask you to do things a little bit different because if we're getting ready to graph this, you don't have to do this part yet, is that if you're going to graph this equation, more than likely, sometimes, -1, 7 is not going to be on the list. Most of the times, that's where, if you're actually going to graph these, this is where, and again, you don't have to write this down. It's just me kind of showing you here. If they actually want you to graph this one, this would be where you would take the -4 and multiply it out over here. You'd have -4x minus 4. And then you want the y to get by itself, so then you would add 7 to both sides. That way you could put it back into y equals mx plus b form, and then you could go back and graph this one and go from there. So a lot of times that's maybe what they ask you to do, is to ask you just to kind of get here. So a lot of times this is like part A. They'll ask you to start here. And then part B, they would say, all right, now go ahead and multiply this thing out and get the numbers that you're looking for. But in some cases, though, some of the questions in the homework, though, that's it. That's all you're going to do is you're just going to put this number here, and then you're going to stop. There'll be a few questions that they'll say, all right, now take this thing, write it out in y equals mx plus b form, and then go graph it, and then you're okay. Okay. But that one, it's always the same two things. Just distributed property here, and then after you got your distributed property, you're going to add or subtract away this number to bring it over here, and then you got everything you need to graph it from there. Okay. So it says to write a linear equation with 2 points, x1 and y1, you got to use your slope formula. And again, we looked at this one last time. So when you're doing your slope formula here, which is your m value, that's where you can do y2 minus y1 over x2 minus x1. Okay. And then once you've got your slope, then you turn back around and plug it back into this formula again. Okay, so number 3, we're going to go ahead and do everything on number 3. And just to make sure we've got plenty of room, we're actually going to do the slope over here just to make sure we got it. So here's your x1 and y1. There's x2 and y2. Okay, so we're going to take those numbers, plug it back into this equation so we can see what we have there. So on the top part, y2 is 7 minus y1 is 1. On the bottom part, x2 is negative 3 minus, and again, we're going to plug in a negative 6 there. So we'll do that just to make sure we got it. 7 minus 1 is 6. You're going to have negative 3. And again, you've got your minus negative, so you're really going to make that negative 3 plus 6. If you do negative 3 plus 6, that's really just 3. So then you've got 6 divided by 3, so that would equal 2. Okay, so anytime they give you 2 points, you pretty much guaranteed you've got to find the slope. And now that you know your slope value is 2, now you can take your slope value of 2, your x1 and your y1, and then you can plug that back into this formula that you have over here. Okay, so if we do that, now we're going to have y minus y1, which is 1, equals our m value here, which is 2, times x minus x1, which is negative 6. All right, and again, only one thing to do for that one, just clean up that minus negative and make it a positive. All right, now if anybody's thinking, again, if anybody's thinking this, somebody may be asking, well, what if I don't label this x1 and y1? What if I label this x1 and y1 and label this x2 and y2? On the test, there's actually 2 correct answers you can have for this one. That if you thought that if you use this for x1 and y1, you could still take your slope that's here, that's 2, and you could plug it back in. So you actually could do y minus 7 equals 2 times x minus negative 3. So the y minus 7 equals 2 times x plus 3. So that's a correct answer, and that's a correct answer. And you may be saying, well, how can there be 2 correct answers? Well, if we did like we did back here where we took this thing and did distributed property and worked this part of it out back up here, you get the same answer. And again, you don't have to write this down. If you just kind of watch it and be okay. If you do 2 times x and 2 times 6, then we're going to add 1 to both sides. You get 2x plus 13. Okay, and then if we took, like we did up here, if we took this and plug in this point, multiply by 2, we're going to add 7. You still get 2x plus 13. So if it's a part A and a part B, there's actually 2 correct answers. Now, unless they tell you that specifically you have to use this for x1 and y1. If they don't, there's 2 answers. This could be an answer, and then this one also could be an answer if you go through that. Okay, and same thing test-wise. If they say leave it here, there's actually 2 correct answers that you have as you go through these things. Okay, so instead of doing a bunch of the other ones here, we're going to make sure we'll do at least number 6 because, again, we'll need some room on this one. And then we'll tie in some other stuff here. So for number 6, there's x1 and y1 and x2 and y2. Okay, and for slope, again, it's y2 minus y1, so that's -3 minus -3 over -2 minus -8. So it's -3 plus 3 over -2 plus 8. So that's 0 over 6. Okay, now if you're not really sure on the answers, what do you do to make sure you got the correct answer for slope? What do you say we want to do if you're not sure? Use your calculator, right? So if you're not sure if it's 0 over 6, just go back and check and see. If you do 0 divided by 6, it's going to tell us either it's 0 or it's undefined. If 0 is on top, the answer is just 0. Okay, again, if it was the other way around, if it had been 6 divided by 0, if we check that one, then that's when we figure out, oh, that's no slope or undefined for that one. But in this case, we had 0 over 6, so the answer is just 0 for that part. Okay, so we got our slope is 0. And again, we'll go back and use this one for x1 and y1. And then we'll just plug everything back in. So we got y minus -3 equals, our slope is 0 times x minus -8. All right, so make that y plus 3. Okay, on the right-hand side, what happens when you do 0 times x? Why don't you do 0 times anything? You get 0, right? If we do 0 times 8, that's 0. So everything on this side, you get 0 here, you get 0 here. So that's just y plus 3 equals 0. And we're still going to go ahead and get y by itself. So we're going to subtract 3 from both sides. So then the final answer for this one is you get y equals -3. Okay, and you may be saying, well, that doesn't look anything like that. And they might actually let you leave it like this. I doubt it, because probably in this case they want to go ahead and get the y by itself. And if you get this one, that's where you're going to have either a horizontal or a vertical line. Because again, you've only got the one letter, so that means it's either going to be vertical or horizontal. And if you do that, if you did graph this one real quick, you go to -3 on the y-axis, which would be like down here. And again, if it's y equals, you can only hit the y-axis there, so that's going to make it go side to side. Because again, slope is 0, right? And if the slope is 0, it's got to be a horizontal line, because again, the z's have got to match up for that one. So that's a little bit of a trick question. If you're ever doing a problem and you figure out that your slope is 0, just remember, if the slope is 0, you know it's going to have to be a horizontal line. And that's kind of what we were talking about the other day, to kind of one of those little trick questions that you can kind of help yourself out just a little bit there. Okay, and then on the bottom, we're going to just do one side on this one here. Might do both here. It says slope-intercept form. Slope-intercept form is where we're doing y equals mx plus b. So that's where they would actually want you to go back and graph this thing. So it says a cab ride costs $4 plus $1.75 per mile. It says write an equation to represent the cab fare and define your variables. Okay, so if you sit down, if you don't go any miles, let's say you only go like a foot, it's going to cost you $4, right? So the beginning amount you've got to pay here is $4. And then your slope, so for then every mile after that, every mile you go over, you got to go up $1.75 in your pay. So this $1.70 per mile, that's basically like your slope. So that would be your 1.75, would be kind of like your slope there. So So when y equals mx plus b, we said the slope is $1.75 and the b value is 4. Okay. Now Uber's kind of changing things, or um, in the online driving or the new driving places we've got, we're going through that. Um, that a lot of those places now, they don't cab drives. They still charge you so much for the first little bit, and then so much per mile after that. Everything now, if you do Uber or anything like that, they say, all right, here's the cost. It's $20 or 30 or 50 or 80, whatever it is you're going to go for. So that one's a little bit different for some stuff. But if you still go ride in a cab somewhere, they're going to do the same thing. They charge you a flat rate fee for this much, and then they charge you so much per mile after that. Okay. Oh, and then back over here for this one. Y would be your dollar amount. Then X is going to be over how many miles you're going to go. Okay. And again, on all those things, if you kind of think about, what's going to be what on those, if you just think about that, if I don't go anywhere, if I just sit down in this cab, how much is it going to cost me? That's going to let you know that if I just sit down and if I go 1 foot, it's going to cost me $4. That's always going to be your B amount. Was basically what happens if I don't do anything. That's always going to be the B amount that you're looking for. All right, flip over to the back. All right, here's the main thing. This is kind of the stuff we're going to work on, and this is kind of building up to where we're going for a lot of stuff. That's still, the other side was still some review stuff, more like a bell ringer activity. This is really like the new stuff that we're looking at. Okay, and with interval notation. Now, if you notice, we've got graphs over here. We're going to actually back up here for just a second. Make sure we back up from that. Make sure everybody's good when we're graphing inequalities. All right, does everybody remember how to graph like x is less than 4? Okay, so that's your number line where you got 3, 4. And again, we're not going to do like down here where they've got like 10 different numbers. We're just going to do a couple numbers right around it. So if we're doing x is less than 4, and that's our number line 3, 4, 5. Y'all remember open circle or solid circle there? Anybody remember? Better take a guess. Yeah. Yep, it's open. So if it's just less than or just greater than, it's going to be an open circle. And if nobody's ever told you this, then shame on them for not telling you this. If you put the X first, the arrow tells you which way to go. Notice the arrow is pointed to the left. That means this arrow and that less than symbol have to be the same thing. This will always be the same as that. That they should match up. That way it tells you which way to graph and shade on this thing. You know you got to go this way. So did everybody tell y'all that when y'all were younger, when y'all were doing stuff? Okay, I don't know how people didn't tell you that, because that's like the easiest thing in the world. Because I got messed up on graphs one time because somebody was telling me something, and this was like middle school, and then finally somebody's like, "Hey, just look at the arrow. Like this arrow. Now you have to put the X first. As long as you put the X first, this arrow always matches up with which side you need to shade." Okay, so if we're gonna do X is greater than -10, let's do greater than or equal to. -10 in the middle. We put -9 over here, -11 over there. All right. So if less than is an open circle, if you put the bar underneath it, make it a solid circle. And again, as long as you put the X first, the arrow looks like this. So when you shade it, you need the same arrow looking the exact same way. So if nobody ever showed you that, then again, shame on them for not showing you, because that's like they should. I don't know why people don't do that. Maybe they just didn't notice it, didn't see it. But anyway, there you go. Okay, so that's the old graphing that we had kind of done. We're still going to do a little bit of that to start with, but we're also going to throw something new at you here, which they call interval notation. Okay, and what they're going to do is eventually they're going to get to the point where we're going to solve some equations and do some stuff, and they're not going to have you graph it. They're going to say, all right, you're going to solve it, and then you're going to write your answer in interval notation. So this is kind of that step in between where we're going to show you how to get to this thing, but we're going to use the graphs to get there, and then eventually we're going to take the graphs away from it. Okay, so if we were doing less than or greater than, this was an open circle. Okay, and with interval notation, now you're going to use a parentheses. Because again, we're going to take this graph. So basically what we're going to do is we're going to solve this inequality. You're going to graph it, and then underneath it, we're going to put interval notation down here. So you can see how this thing lays out. Okay, so less than, greater than, instead of an open circle like this, when we describe interval notation, we're going to use a parentheses, which is going to be something like that. Okay, and if you had less than, equal to, or greater than equal to, this was a solid circle. Like spell solid. There we go. So now it's going to be a square bracket. Okay, and when they do the square brackets, it's just that it's like a staple. Let's turn sideways. So it looks something like that. Okay, now one little exception to the rule we'll put down here. If you use negative infinity or infinity, you're always going to use parentheses. It doesn't matter. So, because a lot of times we'll do something like this and they'll go, oh, it's less than or greater than. We got to use a square bracket. Well, if it's parentheses or if it's absolute value, try again. If it's infinity or negative infinity, it doesn't matter what it is, that no matter what you do with infinity, you always use a parentheses when you talk about describing that one with interval notation. Okay. Oh, and now one other thing when you do interval notation. The smallest number goes first every single time. Because we were doing this one year, and when we were doing, as we were setting this up, and they put two numbers in there. And I was like, well, why didn't you put the smallest number on the left? And they were like, you didn't tell us to. I was like, okay. So now I make sure that when we talk about interval notation, if we've got two numbers, you always make sure you put your smallest number on the left as we're going through this thing. Okay. So here's where we're going to tie all this together. We've got everything kind of set up here. Here's what all this means as we're going to go through this stuff. Okay, so for the very first one, basically is this one. Now, this is, again, kind of reviewing. That basically, x is stuck between -3 and 5. So if you're going to graph this one, and we'll skip the interval notation here in just a second. If you had to graph this one, this is where, again, with it being this part of it, you put a solid circle at -3. You put an open circle at 5. And because x is in between those two things, that's why this has got a solid circle here, open circle here, and then basically just shade everything in between. So if they put x in between two numbers, you just shade in between those two numbers. It's there. Okay, and then for interval notation, what you're going to do is you're going to basically take this graph you have. You tell me what's the lowest number on the left. That's -3. Give me your biggest number, which is on your right side, which is 5. So we're going to go from -5 or -3 to 5. And because that had solid circle, we put the square bracket 5 had an open circle, so we put parentheses. All right, and then with number 2, or x greater than 2, if you graph that one, you'd put an open circle at 2. Again, arrow is pointed this way, so we're going to shade everything out this way. Okay, now this is the kind of new part, because I don't think you would have talked about this back in Algebra 1. No, you didn't talk about it in geometry. 2 is your lowest number over here, so that's why we start with 2. This thing goes forever, right? So by going forever, that means you don't go till you stop till you get to infinity. So that one, you just keep going forever as you go through that thing. Okay. All right, now number 3. This is the first one we actually get to graph up here. So when you graph this one, and again, you don't have to put every single number like they did. If you just want to put, 2, 3, and 4, I'm good with that. We don't have to put, -5, negative, no. Just give me the number we're going to graph and put one number on either side of it just to make it go quicker. All right, so if we got to graph this thing, solid circle or open circle? Solid circle. All right, let's get the easy things out of the way first. We're going that way. And again, as long as X is first, this arrow tells you which way to go. So that arrow has to be the same as that arrow, so that means we got to shade this thing to the left. So that's what our graph is going to look like. All right, now here's the new thing. This is where interval notation comes in. If this is the graph we're looking at, and I almost wish they'd put this underneath it and not beside it, but I couldn't find one where it did that. If this is what we're looking at, what's the number farthest to the left here? Well, I mean, because again, this keeps going forever, right? So because we're shading this thing in, it goes forever this way. It's going to be eventually gets negatives. That's where we're going to have negative infinity. When you get to the right side of it, it stops at 3. It's a solid circle. So interval notation is going to look like that. So you tell me this thing goes forever this way. So forever this way is negative infinity. When we go this way, we get to 3 and we stop. So interval notation is going to be that. It's going to be negative infinity to 3. Okay, now, and again, somebody may be saying, well, if 3 has got a square bracket on it because it's solid, why don't we put one here? If you remember about the square brackets, 3 means you get to stop at that point. So when you have a solid circle at 3, that means you stop at 3. Which means you cannot get any bigger than 3. You cannot get to 3.01 or 3.001, anything like that. If it's infinity, how can you stop at infinity? Because infinity means you go forever, right? So if it's infinity, there is no stopping, which means it goes forever and ever and ever. So even if you've got a solid circle here, somebody tell me how you stop at infinity. Well, you can't, right? Because it goes forever. So no matter what you do with infinity or negative infinity, that one you always have to use parentheses because there's no stopping because it's infinity. So it just goes forever as you go through that one. Okay, so that's what we're saying back up here. No matter what you do, if you talk about negative infinity or infinity, you always use a parentheses. You don't get to use a square bracket on it. Okay, so for this one, number 2 is negative infinity to 4. Almost exact same answer as this one. Okay, so this time we've got a open circle at 4. And we're going to negative infinity, so in that case, that means it should go that way, because we got to get to negative infinity. Okay, and notice how this time we're going to negative infinity, how your arrow is pointed to the left. Same thing, the arrow's got to point the same way. So we're going to do x less than, it's going to be an open circle because of the parentheses here, and then you just tell me the number we had there. So it's going to be x less than 4. Okay, so they're trying to take the things that you've done in the past with the greater thans and the less thans in the graphs and trying to use those two things to kind of get you to think about what interval notation is. Because a lot of the stuff we're going to do, it's always going to go back to interval notation for some stuff that's here. Okay, so for number 3, graph goes from here to here, right? It's going from 2 to 6. So lowest number on the left is 2. The biggest number on the right is 6. So it's going to go from 2 to 6. 2's got a solid circle, so you put a square bracket there. 6 also solid circle, so you put a square bracket there. And that's it. That's all you have to do for interval notation. Okay, now when asked for the inequality, here's what you're going to do. Because we need everything between 2 and 6. So basically you put the 2 over here, you put the 6 over here, and you put the x in the middle. Okay, and because it's got the solid circle, we're going to put a less than equal to with that part of it. And we'll put a less than equal to with that part of it. And as long as x is in the middle, both of them will always be less than, because basically what they're doing is, and I'll kind of show you this one. Again, you don't have to write this down. Is you may be saying, well, I thought we always put the x first. Well, if we put this x first, if this is what we were doing, and we cover this part of it up, that would be everything greater than 2. So that's why we've got everything at 2 going this way. But then once you get to 6, you got to keep it less than 6. So they've got that. So they just kind of reversed these two things around and put the 2 first and put the x here. So we can do that. All right, so 4. We've got 5 to infinity. And again, we know the numbers keep going forever in either direction, but we're just going to label the couple of numbers we've got there around it. You got a square bracket on 5. So solid circle. It's going to infinity, and infinity's over here, so it's going to go that way. All right, and again, with the arrow going this way on the graph, when we go write the inequality, it's going to go the same way. It is a solid circle, so we're going to put the bar underneath it. And again, we're starting at 5, so we'll put the 5 there. Okay, for number 5, we've got the graph, and again, 1 is on the right side. It goes forever this way, so it's negative infinity. We're going to go from negative infinity up to 1, and again, 1 is solid, so we'll put the square bracket on it there. All right, again, the way it's shaded off to the left, so it means that has to match that. Solid circle, so we'll put the bar underneath it, and we'll do x, and again it stopped at 1, so we'll do x less than equal to 1. Okay, and again, just trying to tie everything together because it all just kind of matches up when you talk about, you know, the equation and the inequality and the graph. That they all just kind of piece together because they're all going to spin off of it. We're going to skip 6 for now. We'll come back to it here in just a minute. 7, it's going from -5 to -1. Because -5, farthest number on the left, -1, farthest number on the right. Both of those are open circles. So both of those are parentheses. Okay, and if it's that way where it stops on the ends, we're just going to put -5 on the left, -1 on the right. We're going to put x in the middle, and we're just going to put less thans on either side of it there. Again, x is stuck between -5 and -1. Okay, 8 is a trick question. It says x is any real number. Okay, well, if that's any number, that means you can touch anything on here. So it's going to be one of those things where if they graph this one, you're just going to shade the whole entire graph. Okay, so it goes forever back here to negative infinity, and it never stops. It also goes out to positive infinity. So we're just going to put that to do that. And that's another way that sometimes when they'll say instead of, I think one of the questions we were talking about the other day, one of the special cases, instead of saying like we had no solution and we had infinitely many solutions, this is another way of saying like infinitely many solutions, that all the numbers are going to work for this thing. All right, we're going to skip over 9. We'll come back to it here in just a minute. All right, so for 10, we're going from 1 to 4. All right, open circle at 1, open circle at 4, and if it's 1 to 4, it's going to keep everything in between those two numbers. Okay, and again, we're going to keep it between 1 and 4, so 1 over here, 4 over here. We're going to put X in the middle, and again, we're just going to put a less than on both of those. All right, here's what I want you to do. Take a couple of minutes. Go ahead and do numbers 11 and 12. See what you think. If you're using a pen and you want to make sure you can like scribble it somewhere else, just do those two at the bottom. See what you think you get, and we'll come back and check those here in just a second. All right, see what we got here. All right, so if you graph these, you've got X is greater than 7. 7, 8. Again, it's greater than 7, so it should be an open circle at 7. And again, arrow looks like this. So when you shade it, you got to have the arrow that fits on the line that looks the same way. So it should be going that way. All right, and in interval notation, you got an open circle at 7. Goes out to infinity. So you should have something that looks kind of like that. Okay, and then number 12, you've got negative 2 to 2. X is in the middle. They're both square brackets. So because of the square brackets it's there, that means when you do the less thans, they need to have the bars underneath them. Okay. So for this one, negative 2, again, square bracket, which means it's a solid circle. Positive 2, also a solid circle. And that should just be everything in between. Okay, and then we're going to back up and get the other two, because I'm going to get all the other, because those are all pretty much similar as we're doing that one. 6 and 9 are the two that are kind of different from everything that's here. If they give you an OR statement like this, when you go to do your graph, basically it's going to be like a 2-part graph. So with X less than 1, for that part of it, you can do an open circle at 1 and go, because again, that arrow is pointed this way, so I need that arrow going that way. Okay. We do the X greater than or equal to 5. That part of it's a solid circle at 5. It's greater than or equal to, again, your arrow is pointed like this, so you got to make the arrow point in that same direction. It's going to go that way. So it's going to be, if it's an OR statement, it should be a 2-part graph. All right, and when you do interval notation, it'll be a 2-part interval notation, because you'll do this part first. So that's negative infinity up to 1. 1's open circle, so it's parentheses. And then in the middle, to show that we're going to jump from here to here, you put a U, which stands for union. So we're going to put this part together and we're going to combine it with that part together that's over here. 5 is a solid circle and it goes out to infinity. So when they give you an OR, it's going to be a 2-part graph as you go through those. Okay. And then number 9 is basically the exact same thing. It's just they're doing number 9 in reverse. They give you a 2-part graph and say, okay, now we've got the 2-part graph here. Let's turn around and show what the inequality is going to be. So again, you do it in 2 parts. That part of the graph that's here, we do it in red. That's everything. That's solid circle at -1. That's going to be x is less than or equal to -1. The right-hand part of the graph, we've got an open circle at 2. This one's headed off that direction, so that would be x greater than 2. And if it's a 2-part graph, we're just going to put an OR in the middle of it. Okay, and then interval notation, again, if you look at that part, this goes to -infinity on the left side. It stops when you get to -1. It's solid, so it's a square bracket. Picks back up at 2 and goes out to +infinity. And again, their symbol that they'll do to show the OR part is here, is they put the U in there. Okay, now that's the beginning of interval notation. It's just making sure you kind of get comfortable that it's just taking the numbers you have in a graph and just putting them here that you tell me the lowest number first and then your biggest number second, and then you just use parentheses or brackets to say either we make the solid circle or make an open circle as you go through those. Okay.